Okay, so let's go through the homework solutions from last Thursday. Hopefully you had a nice break over the weekend, and prior to that you were able to work these out. So question 9 has a table, and in the table they have the equation of the line. The first one is y equals 2x minus 4. That's the line J. And they ask us to write down its slope. So the slope, this line is already in the form y equals mx plus c. So y equals mx plus c, meaning that the slope is the number in front of the x coordinate. So the slope here must be 2. If you want to, it's probably good practice to write down m equals 2. And then the y-intercept, the place where it crosses the y-axis, is always c. So including the sign, minus 4. And again, it's good practice to write down y equals minus 4. You can also write this in point form, and it will be the point 0 minus 4. The x value is 0, and the y value, y equals minus 4. Okay? Right, the second line then was the line K, and that was y equals 4 over 3x minus 7 over 3. So we have fractions, and it's fine to have fractions for slopes in particular. M equals 4 over 3, and y equals minus 7 over 3. Okay, so that's all we needed to do there to fill in that table. The second part of the question asked us to use algebra. So when they say use algebra, you can't do it by graphing, because if you do it by graphing, you won't get your full marks. So I've got equation 1, I'm going to call J equation 1, and equation 2, K, is what I'm calling equation 2, just so that our calculations look like what we've done before. Now, when they're all set up as y equals mx plus c, the easiest thing to do is just subtract equation 2. So I'm going to cancel y, and I'm going to do it by not changing, no change to equation 1. So I'll just write it down exactly as it is, and I'm going to subtract equation 2. Means that I have to change every single sign. Of course, we have fractions in equation 2, but that's okay. So minus y equals minus 4/3 x plus 7 over 3. So I've changed the sign of the y, I've changed the sign of the x, and I've changed the sign of the constant. Now what happens? The y's cancel, giving me 0. And what do I do with the x's? Now, you don't have to use a calculator to do this. Plenty of people are really good at doing these without a calculator, but there's no marks going for showing the work, and this can help you not make a mistake. So what am I doing there? I'm subtracting the coefficients. 2, take 4/3, gives me 2/3. 2/3 x, and what about this? Minus 4, where's the minus 4 coming from? There, plus 7 over 3. That's the constants, giving me minus 5 over 3. Minus 5 over 3. So now what I actually need to solve to find x, I'm trying to solve 2/3, or 2x over 3, minus 5/3, 5 over 3, equals 0. And we know how to deal with these. We need our common denominator, which is, of course, is going to be 3. And we multiply each part of the fraction by that common denominator. When there's a fraction, the denominator divides in. It divides in to give 1 there. So there's nothing left to multiply, because 1 times everything, or anything, just gives you the same number. So 2x minus 5 is equal to 0. 2x is equal to 5, and x is equal to 5 over 2, or probably more convenient to write that down as 2.5. So x is equal to 2.5. What about the y value? We substitute it back in. It doesn't matter which one we pick. This one looks easier though. Y is equal to 2 times 2.5 minus 4. You can type that into your calculator or work it out. That's 5 take 4, which is 1. So y is equal to 1. Now you will get full marks for that most of the time, but let's be completely proper with this and write down our answer, the point of intersection. And because it's a point, we need to write it in x comma y format. So the point of intersection is x comma y, 2.5 comma 1. So that was the full question for question 9. We wrote down the slopes and the y-intercepts. We didn't do anything with them other than writing them down. And then we solved simultaneous equations to get the point of intersection. If you were to draw the graphs of those lines, you'd find that they cross over at this point, so long as you were accurate in your graph drawing. Now, question 10. We're given 2 points, A, which is 2, 2, and B, which is minus 4, 6, and we're asked to plot those points. So when I'm plotting these, I need to, I'm going to use a fresh sheet of paper, just so I've got plenty of space. I need to go between minus 4 and 2 in the x direction and 2 and 6 in the y direction. We'll go a little bit further than that even. So plot my points and make sure that I've got plenty of space. Here's my x, here's my y. Has that gone off the screen? The y has gone off the screen a little bit. There we go. And we'll put numbers on our axes, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3. I can always extend this if I don't have enough space to do whatever I'm being asked to do. 4, 5, 6, and minus 1, minus 2, minus 3, minus 4, minus 5. So I was asked to plot the points 2, 2, 2, 2. So that's the point A. I like to write the coordinates in next to it, but you don't have to. And B, which is minus 4, 6. So minus 4, and then up as far as 6. So that's the point B, minus 4, 6. Okay, the next part of the question then said, find C, the midpoint. So you could technically join those lines together, measure it, and work out where the midpoint is, but we have a formula for midpoint, which is always likely to be more accurate than anything we draw. If I measure those, about 7 centimeters between them, so my midpoint should be, I expect my midpoint to be there, minus 1, 4. But let's do it using our formula. So remember the midpoint formula. This was a little bit of revision for us, so we hadn't done coordinate geometry in a while. This is our first point, x and y. This is our second point, x and y. And the midpoint is always going to be the average of the x coordinates, comma, the average of the y coordinates. So you practiced a lot with those a few weeks ago. So my midpoint will be 2 minus 4 over 2, comma, 2 plus 6 over 2, which indeed gives me minus 2 over 2 and minus 1, and 8 over 2, 4, which is exactly what I thought it was going to be. It's called P, that point there, and that is minus 1, 4, as I expected. Now, verify that the distance from, oh, they said C should be my midpoint, sorry. C should be my midpoint. So these are the coordinates of C. They asked me to verify that the distance from A to C is equal to the distance from C to B. So A to C, A is 2, 2, C is minus 1, 4. And again, I'm going to use my distance formula. Now you might have forgotten, after dropping the pen, it's okay. You might have forgotten that the distance formula is the square root of the difference between the x values squared plus the difference between the y values squared. So that formula is in our log tables, of course. And that's my first point, that's my second point. It doesn't actually matter which one you call the first point and which one you call the second point, because distance is the same regardless which direction you go in. So the distance from A to C, that's what this notation means, is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. You can just put that into your calculator in one go or work it out. We've got 9 plus 4, which is the square root of 13. And the square root of 13, don't bother writing it as a decimal or anything like that. So the square root of 13, your calculator will just write it as the square root of 13. Leave it like that. That has a special name in maths. It's called surd form. And when we do more with surds, you'll learn a bit more with that. Okay, the second part of this question then was to find the distance from C to B. So C is minus 1, 4 and B is minus 4, 6. And again, we're going to use the distance formula. I've written it down here, but this time this is my first point and this is my second point. So when I fill in, the distance from C to B is the square root of x2 minus a minus gives me plus, plus y2 minus 4, and that again gives me the square root of 13. This is enough. You don't need to show any more working out than this. You can say, well, this is minus 3 squared, which is 9. This is minus 2 squared, which is 4. 9 and 4 is 13. But you don't need to show it. So we do need to draw our conclusion, though, and say, therefore, the distance from A to C is equal to the distance from C to B. So that's what we were asked for there. Okay, next we were asked to find the slope of this line. So we're asked for the slope of A to B. Okay, so the slope A is 2, 2. B is minus 4, 6. Could we do it from our diagram? We could. We could use rise over run. It's a negative slope. So my rise will be minus. My rise is minus 2 spaces down like that. And my run, 1, 2, 3. My run is 3. So I could just write down rise over run equal to minus 2 over 3. And if I've shown my work on my graph like this, I'll get full marks. But let's also do it using the formula. So the slope formula says it's the difference between the y values divided by the difference between the x values when you have 2 points. So my slope will be 6 minus 2 divided by minus 4 minus 2, which gives me 4 over minus 6, which, remember that minus, I can move it up and down and into the middle. That is the same as minus 2/3. So whichever method you prefer is fine. If you do use the graph, make sure you show it nice and clearly on the graph, the work that you've done. Next, part D. That was part D. Next, part E. Find the coordinates of the point where AB cuts the y-axis. Okay, I can see from my graph that it cuts the y-axis roughly at about 1/3 of the way between 3 and 4. So it looks like 0 for the x and 3.3. But that's not accurate and we won't get full marks because I don't know if that's 1/3 of the way through or 2/5 of the way through. I'm not entirely sure. So how do you find the coordinates of where something cuts the y-axis then? You need the equation of the line formula. So we need the line formula. And I'm surprised they didn't step us through asking that. So remember, the equation of a line is y minus y1 equals m by x minus x1, where what? x1, y1 is any point that's on the line, so we'll use a, which is 2, 2, and the slope is m. So m is minus 2/3. I don't know why I put it in brackets. I didn't need to. So my equation of the line is y minus y1 equal to m by x minus x1. And we don't leave it like that. We multiply the y side. What we're actually doing there is multiplying by my common denominator. We multiply the y side by 3 to get 3 by y minus 2. And we multiply the x side by the numerator minus 2x minus 2. That gives me 3y minus 6 equals minus 2x plus 4. And we've got 3y minus 6, sorry, I didn't do anything there. 3y is equal to minus 2x plus 4 plus 6. What am I doing here? I'm not doing what we normally do. Instead of bringing everything to one side, which you can still do, I'm getting y on its own. So y is equal to minus 2/3 x plus 10 over 3. I'm dividing everything by 3, which I can do because I can do whatever I want to an equation, so long as I do it to both sides of the equation. Now, I have my line in the form y equals mx plus c, and c is my y-intercept. So they asked me in part E to find the coordinates of the point. Coordinates means I must write them in x, y format. So the y-intercept is at y equal to 10 over 3, or 3.3333 1/3. So the coordinates, be careful to answer what they ask you for. X is 0, y is 10 over 3. 10 over 3 is 3.333333. So we were right, it was 1/3 of the way. What it looked like was what it was. Okay, how do I then find the coordinates of where it cuts the x-axis? So it cuts the x-axis wherever y is equal to 0. Why is that?